Hello everyone, in this tutorial I'll take you through localization concept that which belongs to module 5 of wireless sensor network. So before going through the challenges in localization, let's go through this localization a bit. So localization protocols can broadly be classified into two categories. One is range-based localization protocols and range-free localization protocols. Range-based localization protocols, here the protocols require the existence of beacon nodes that have accurate location information. So here range-based localization involves beacon nodes. Beacon nodes are the special category of nodes. And whereas range-free localization protocols is where they don't require distance estimation, while the existence of beacon nodes may still be required. So they would be requiring these beacon nodes, but they won't require them to calculate this distance estimation. The location of other nodes is estimated through range-free technique. And now let's go through this challenges in localization. The very first challenge is physical layer measurements, followed by computational constraints, lack of GPS, low-end sensor node. So these are all the different challenges with respect to this localization. So now let's take up the very first challenge, that is physical layer measurements. Most localization protocols rely on techniques for localization. These techniques provide local information in terms of distance and orientation to a neighbor node. Received signal strength, RSS, or timing information can be converted into distance measurement. Node A transmits a signal to node B, which estimates node's A portion through ranging techniques. It is assumed that the received signal sent from node A travels a direct path to node B. Node B can estimate the angle of arrival, that is theta cap, and distance d cap with respect to node A. So let's say there are two nodes, node A and node B, and let's say node A is transmitting a signal to node B, and this node B can estimate the portion, that is this estimate, this angle with respect to the normal as well as the distance d cap. So this is ranging measurements with line of sight communication. So that is this difficulty. As you can see, there is a drift in the actual distance as well as the angle. This is the true angle theta, whereas this is the estimated angle, and this is the actual distance d, and this is the estimated distance t. So these are all the challenges in localization, that is physical layer measurements. The next challenge is computational constraints. Local information from several neighbor nodes in terms of distance, orientation, or connectivity is usually combined to provide location estimates through multiple measurements. So here only by multiple measurements we can have a clear estimate of the location. Location of a node can be estimated through maximum likelihood function (ML) technique, but it consumes more power. So thereby protocols with simple and distributed localization algorithms are suitable over here, unlike making use of this maximum likelihood, that which gives the precise location of a node, but it consumes a lot of energy. Then we have this lack of GPS, global positioning system. GPS is utilized for location services in several embedded systems such as cell phones, navigation systems, and laptops. GPS may not be feasible for most wireless sensor network deployments because these GPS units are very costly, that is, they exceed almost 3 times the cost of the actual sensor node. So GPS operation has a high energy consumption profile. So because wireless sensor nodes are all battery operated, so they cannot deal with this very high consumption profile kind of components. Wireless sensor networks are usually static, and localization protocols may be required to run only during initialization. So only during initialization we need to run this localization protocols. And most of these nodes are static in nature. So thereby only during The initialization process, we need this localization information or the location information. GPS can still be used with a limited number of nodes to serve as beacon nodes. And finally, we have this final challenge with localization, that is low-end sensor nodes. Wireless sensor nodes are equipped with low-end components to provide low-cost operation. Erroneous, there's a typo mistake. Erroneous hardware on sensors also introduce errors in the range calculation. In a similar way, transceiver imperfection causes received signal strength measurements noisy. Low-end crystal results in erroneous timing measurements. So these are all the challenges with respect to localization. Thanks for watching.